Hey, hello again. Today I would like to show you how to create this kind of line-based halftone shader using GhGL from Grasshopper, a new feature from Rhino work in progress. And the theme here is to change the thickness of the line based on the shade on the geometry, input geometry like this, so that it will look like 3D geometry, even though the direction of the line is straight like this. And you can also change the direction of these lines like this using this MD sliders. You can also change the division thickness. This. You can also change the base thickness of this black line, the minimum and maximum. So minimum controls the minimum thickness of this lighter areas. The maximum thickness value will control the value on the shader, more shaded area. And you can also reverse this to make like a backlighted geometry, which looks also interesting by flipping the value. Okay, so that's what I'm gonna make today. Let's start doing it. Now, before doing that, as always for this Grasshopper GhGL shader, you have to install a package called GhGL from a package manager. So open the package manager if you're using Rhino work in progress, the newest version of work in progress version, which is Rhino 7. And then go to go search for GhGL, which should be somewhere here, and install the newest version, which is available. Right. Now, after you have installed and restart your Rhino, you should see a component called Mesh Shader, GL Mesh Shader. So this is what I'm gonna use today. Right. Now, let's first import some geometry that I want to use to put a shader on. So I am going to import the Stanford bunny. And this is a bit small, so let's scale this up to something by 100. Right. And let's also rotate this bunny so that it will stand up on the XY plane like this. Okay, that looks good. Now let's import this geometry in Grasshopper using mesh component or geometry component and select set one geometry. Right, then let's hide this on Rhino and just show this Grasshopper and connect this to the GL Mesh Shader. Right, and let's also hide this. Now, let's start. Now, first thing is what I'm going to do now is to set some parameters that I want to control. So first of all, I want to control the direction of the halftone lines. So and that is going to be based on the screen coordinates, so which it will be a vector 2D vector. So I'm going to just use MD slider to control the 2D vector. And also from this MD sliders, I might want to change the region from minus, I guess this is okay. 0 to 1 is okay, I guess. And let's make some input to this GL Mesh Shader. First of all, I am gonna name this to deer as a direction and connect with the MD slider so that I can control the direction of the halftone lines. And also I am going to make another input called div, stands for the division length, so that how to control the division, how much the line will be separated to each other. So I'm gonna put some sliders here. I don't know the range yet, so I'm just gonna keep the maximum to 10. Maybe I'm gonna change it later. Oops. Right, and another parameters that I want to set is the minimum thickness of the black line and the maximum thickness of the black line. And I want to set the maximum and minimum to be from 0 to 1, the range from 0 to 1. So let's just create 2 sliders which goes from 0 to 1 and connect to the new parameter. Let's call this min thickness and max thickness. Like this, right? And let's connect this, and I'll set the minimum to close to 0 and set the maximum to close to 1 for now. Right, now everything looks good for the parameters. Let's go dive in and write some code in order to create a halftone code, halftone shaders. Now the first thing I think I only need to go look into this fragment shader. So just open the fragment tab, and first of all let's import those parameters that I made. So first thing, uniform vector 3. Even though this is vector 2, the value itself is 3 vectors, 3D vectors like this. So I'm just gonna say as vector 3 here, and uniform float div division length, and also uniform float minimum thickness, uniform float maximum thickness. Right, make sure there's no errors here. And anything else that I need? Maybe not. Okay, let me just write some additional function except for the main, called map, in order to remap some numbers from range to range, because it's a pretty handful. So you can just search for some code on you can just go to the Google to search for some remap function that you can use on basic any language. So let's search for remap function, and I'll go to the Stack Overflow website, and there are some handful functions which I can use. I guess I could use this one. So let's copy this and paste it here, and I'm gonna add some value here. So I want to return the float value, and I need 5 inputs, value low 1, low 2, high 1, high 2. So so first value, float value, float low 1, which will be the source value for the lower value of the source, float high 1, so source high value, and low 2, which will be the target low value, and high 2, which will be the target high value. And make sure there's no compile errors. Alright, looks good. Okay, let's continue to the fragment shader, and let's first of all, I am going to use some of the code already written here as a template. So other than that, I am going to disable. So first thing I don't need is this diffuse. I also don't need this ambient, so I'll comment this out, this one as well. And I just want to have this intensity, but being changed as an absolute value. So this absolute intensity value will be, let's just show this first, how it looks like. Intensity in vec3. Okay, I'll just set the alpha to 1. So the intensity value is just the shade value here, as you can see. So the edge of the geometry looking dark, which explains that these are the shades based on the light direction which got from the Rhino. So I am going to use this shade information in order to change the thickness of the half film lines. Right, so now that I got intensity, what I want to get now is the screen coordinate for each mesh pixels. So that you can get from a global variable called a frag coordinate. So that is GL frag coord. And let's check how it looks like. And so this is the fragment coordinate value that you can get globally using OpenGL, and it is based on the screen information. I think the left bottom position will be 0, 0, and right top position will be something based on the screen size. So if this is 1920 by 1080, then this point, the right top point, will be around 1920 to 1080. So to check if this value is really that kind of number, let's divide this by a value of 1000 something. And now if I change the position of this bunny from on the screen, I can see that the color is changing based on the screen coordinates. So I think that's I'm getting the right information, right? And I am just using XY value because the screen is in XY, and other values E and W is using, I think, having some depth information or something, probably. I don't know yet. But today I'm just going to use this XY value here. So now that I got the information, let's bring this up here, around here, and let's just pass it to some random variable here for vector 4. Like this. Yeah, I just need a vector 2, so let's just say vector 2 here. And now what I want to do now is to, based on the direction that I have imported as a parameter, which is this one, so this vector, so based on this direction, I want to calculate the distance for each point on the screen based on this direction from the 0, 0, 0 position. So let me explain what I mean in Sketch. Okay, let's say this is the screen that you have and as your display, and this is the 0, 0 position, and this is, I don't know, width and height position, and the direction you have imported from the parameter MD sliders, maybe going somewhere around this direction, and what you want to calculate is the having a virtual line like this going to that direction, going to that specific direction, and actually calculate distance from this 0, 0 position as a perpendicular line like this. And I want to get the direction. If you just pick up any point on the screen, and from that point what I want to calculate is the distance from this 0 to this point position based on this direction that I have inputted like this. So this is the line length that I want to get, distance that I want to get. And having that information, I can divide these lines by a continuous division length, maybe by some value like 10 or 20, like these blue lines, which have a continuous division length like this, so that you can split this line into this kind of a zebra pattern. And from that, by doing this, you can create a halftone shade that I would like to create. So that's the things that I want to do. So in order to calculate this kind of distance, this L distance, using the this inputted or vector direction, what you can do is just calculate. So each point has its own vector, which is from 0, 0, 0 to this point like this. Maybe I'll just write it in black. Right, so you have this coordinate or this direction vector plus a guide direction vector, which is a size of 1. Now, having those two vectors, you can actually calculate the distance, which is perpendicular to this direction, so which means this direction. In order to do that, you just need to use a simple dot product calculation. So calculating the dot product between this direction vector plus this point position vector on the pixel, and the condition is that this direction vector should be a size of 1, then you'll get this length. That's the simple vector calculations that you can look back at high school mathematics, and by using this you can easily get this value. So after that you can easily get the halftone lines based on the division length input that I have created here. Right, so let's do that first. So I already have the point position coordinate position vector from the fragment code. variable, global fragment code variable, and I have just extracted the x and y value. So I also want to extract the x and y value of the direction here. So I'm gonna say dir2d is directions x, y value. I don't need a z value since it's still 0. Right, and next I also want to normalize this just to make sure that the length is 1 for the guide direction. Right, now now that I have two value here, let's calculate the dot product. I'm gonna name this distance. So use dot product to calculate direction 2D and fragment coordinate. Okay, before I continue, I realized I am missing one parameter here. I mean slider here, which is for this main thickness. So let's import that. Let's connect with another sliders here. Right. Okay, so I have every sliders connected. Okay, looks good. Now let's try visualizing this distance value by having it inside the fragment color. So yeah, replace what you have inside of vector 3 with the distance and maybe multiply it by 0.001 or something, because the highest value could be more than 1000. Right, and let's see what it looks like. Maybe I could make it 0.00005. So as you can see, I can see some colors gradation from bottom left to top right, that gradually changing its color to black to white. And if I change the direction, currently the direction is going to the positive x and positive y, but if I change this to more a straight from bottom to top, then the bottom bottom color will be black and the top color will be more white. Let's also change this value a little bit smaller or bigger, like this. So as you can see, based on the direction that I have imported here, the gradient direction is also changing based on this input. Okay, now, all right. Okay, so that looks good. And the next thing I would like to do is to divide this distance into a step value, so that by this division length to divide it, so that I can create a border lines based on this direction or distance. So what I can do for that, I could use a modular calculations to do that. So let's create another variable called mod value or something, and use the mod function for the OpenGL GLSL, and first get the fraction from, or the modular value for using the mod function with this divide length, right? And the result should be a value between 0 to the maximum div. And I also want to change the range of this result to be from 0 to 1, so I am going to additionally divide it by div length so that the range will be from 0 to 1. as a result. And let's check this value again so that I can see if I got the right value to here, mod val. Right, so now I see some border lines based on the direction I have imported here. And if I change this, I can kind of see the direction is changing. And I probably want to change the range from -1 to 1 for X and Y so that I can have more range for the direction. So if I change this direction, I can see that the direction of the borderline is changing based on this input, so that is good. And if I change this division length, maybe let's set the maximum to 50 or something. If I increase it, the thickness of the borderline will be widen up like this. And even if I change the camera position, I could still see the borderline parallel to your camera because it is based on the screen coordinate. And that is good. So next thing, I would like to split this each borderline. So since right now this is a gradation from black to white, but I want to change it to more make it more contrast from black to white, and based on the shade of the geometry, I want to change the thickness of this black line. So first thing I could do is to test out how to split this gradation from to black and white based on the gradation value. So the simplest way is to use a step function. So let's make a step value variable and use a step function. And just for testing, I am gonna say 0.5 as a threshold for the step and change this mod val. So value that is less than mod val, which I've created here, will be 0, and value that is greater than 0.5 will be 1. And let's check this out by replacing this mod val to step val. And something must be wrong. Step val, float step val, undefined variable step val. Am I missing? Okay, spell mistake. Okay, so now that I have more borderline and more contrast, so you have just black and white. But as you can see, the thickness of the black and white is all similar because I'm using the constant value here. So if I change this to 0.1, then the thickness of the black will be smaller, thin. And if I make it to 0.9, then the black line will be more thicker and the white line will be more thinner. So I don't want to use this. I don't want to use constant value in order to change the thickness here, but I want to use the value based on the shade intensity to control the thickness of the lines. And I already have this intensity value here, so let's replace this with intensity and see what happens. And as you can see, I already seem to have a shaded line based on the shade, and right now the division is a bit too big, so let's make it a bit more smaller. As you can see here, I already see some outline halftone shade already been made using this method. And this is pretty much it for the base of the halftone shaders. I just want to add one more function in order to control the maximum thickness and the minimum thickness of this black lines. So for that I need to control the range for this intensity, because this is the one that it's controlling the thickness of the black and white lines here. So this is where I can use this map function that I have implemented here. So use update this intensity using map intensity. So the value, the range, original range is from 0 to 1, and let's change this range to this input that I have right here. So minimum thickness and maximum thickness. So let's copy this for the minimum target, and let's copy this for the maximum target. Right, and everything else looks okay, I think. So let's delete all the things that I don't need and press OK. Let's change the thickness value, and I can see that the thickness of the black line is changing based on these parameter changes. Right. And if I flip this value, the black part will be more black. The darker place will be more darker. I guess this is a... I'm doing reverse ways. This should be maximum. This should be minimum. So let's change the code a bit to flip the minimum maximum. So let's go to the fragment shader and let's just subdivide this intensity by 1 so that it will be flipped. Right? So that looks better. So this is the minimum value for the black line thickness. This is the maximum value for the black line thickness based on a shade. Alright, that looks perfect. That looks good. And this is it. This is how you can create a line-based halftone shader. And based on this technique that I've shown here, I think you can also create a shader, halftone shader, not just based on the line, but probably based on a circles as well, like a comic book or something like that. So yeah, it is an interesting technique, not just for Grasshopper, but any OpenGL based stuff or any shader based language. Okay, that's it for today. Thank you for watching. See you next time.